Welcome to Project Ventive channel. So before get started, make sure to hit the like button, also subscribe to my channel. The company of Vicarious AI, artificial intelligence, is collectively and systematically with the approaches that are being used today. This is continuously not ending technology. Vicarious AI projects give rise to the development of the country through its robotics source. Vicarious is on a journey to achieve what some call the holy grail of artificial intelligence, giving robots the capability to think, act and learn like human beings. Robots today can do many tasks, but they still cannot be as adaptable and flexible in different situations as people. In this endeavor, Vicarious co-founder and CEO Scott Phoenix have the backing of some of the most famous people in technology. Facebook CEO Mark Zuckerberg, Amazon CEO Jeff Bezos, and Tesla CEO Elon Musk, among other luminaries. In 2015, the World Economic Forum named Vicarious among its tech pioneers. It was also a Goldman Sachs pick the same year. Phoenix recently spoke to Knowledge at Wharton about what's ahead for AI. An edited transcript of the conversation follows. Knowledge at Wharton. Vicarious is backed by some of the most famous names in tech, such as Mark Zuckerberg, Jeff Bezos, Elon Musk, Jerry Yang, Peter Thiel, and many others. Scott Phoenix. Many of my personal heroes. Knowledge at Wharton. These are really some big hitters supporting you. What gets them excited about Vicarious? Phoenix. Well, I think that it's getting harder and harder to argue that artificial intelligence is not the next big thing. I think that AI has already come to touch so many different parts of all of our lives. And I think that's only going to get more significant as the future approaches. Knowledge at Wharton. Let's start by explaining what artificial intelligence is, before we get into more detail about what your company's actually doing. What exactly is it, and what are some misconceptions people have about it? Phoenix. The first thing to do is introduce a little bit of a distinction, because there are a lot of misconceptions about artificial intelligence, and I think a lot of them stem from not making this distinction. So, I'd like to put artificial intelligence into two different bins. One is artificial narrow intelligence, and the second is artificial general intelligence. Artificial narrow intelligence, you can think of it as a decrease in the price of prediction. Right now, AI is used to predict all kinds of things, like what ad to show you when you're on Facebook or Twitter or Google, or what person might be in a photograph. So our advances in AI in the last 2 decades, and our advances in computer power and storage and datasets, have led us to a situation where those narrow predictions have gotten cheaper and cheaper and cheaper. And now it's so cheap that you can have systems that predict what word you're saying when you talk to your phone. And that's what gives us Siri. This also includes things like Google DeepMind, AlphaGo, GoPlayer. That's a narrow intelligence that predicts whether a Go board is a winning Go board or a losing Go board. And that's all it does. It's a very narrow intelligence. Now, there's a second kind of intelligence I would call artificial general intelligence. And that's intelligence that, instead of just making predictions about a narrow dataset, is designed so that if you give it the same kind of experiences that human has from birth to adulthood, it'll learn the same kinds of concept and get the kind of abilities that human has. Knowledge at Wharton. Basically, for narrow intelligence, it's a much more limited functionality. Whereas for general intelligence, it functions more like the human brain, and it is adaptable and flexible. Phoenix. Yes. And I wouldn't say one is strictly better or worse than the other, in the sense that narrow intelligences can do all kinds of different things that humans can't do that well. Like, for example, most humans can't play Go very well. But you can build a narrow intelligence to play Go better than any person. And you can build a narrow intelligence that's better at regulating temperatures inside of a data center than any human could. And so that's the advantage of a narrow intelligence. You can design it to be better than any human at tasks that humans aren't necessarily that great at. Or even some tasks that humans are good at, like predicting who's in a photograph. But general intelligence are ones that are limited, in the sense that they focus on doing what humans already do well, controlling a body, understanding human-like concepts, and accomplishing long-term goals. Our research focuses on artificial general intelligence. And specifically, how do you make a robot do all the kinds of things that a human can do? Knowledge at Wharton. And why is that important? Phoenix. It's really important, because right now the world is full of cheap robot parts, like motors and sensors and electricity, and nobody owns any robots. You know, we live in bizarro land, where all of the work that's being done around the world is generally done by human hands. Right now, there's 800,000 humans assembling iPhones, not 800,000 robots. And that's despite the fact that robots are physically capable of doing a lot of these kinds of manual tasks. A robot is perfectly capable of cooking a meal, for example. But no one uses robots to cook meals, because artificial intelligence isn't general enough to allow the robot to do that. So, the reason why Vicarious is focused on artificial general intelligence for robots is that this is a technology that would enable us to live in a world that's a lot more like the Jetsons world. It would let us make labor much more affordable, which would then let us all rise in society. Knowledge at Wharton. And how exactly do you do that? I'm sure that maybe the holy grail for AI is human-level intelligence. What strategy or technology or algorithms are you using to accomplish that? Phoenix. You can think of what we're doing as taking what we've learned and what neuroscience has learned about the brain in the last 30 years, and applying that to building models that work much more like the brain than contemporary artificial intelligence approaches. There's some brain inspiration in today's AI algorithms, but not very much, compared to how much structure we know to be inside the brain. Knowledge at Wharton. You and Dilip George, your co-founder, have mentioned in the past that there's something called the old brain, and something called the new brain. And Vicarious is focused on the new brain. Can you explain that a little bit more? Phoenix. You can think of the old brain as a lot like this narrow intelligence. You have frogs that have a superhuman ability to catch flies. They can catch flies far better than I can. But they're not generally intelligent. And you can think of AlphaGo almost like a frog that only plays Go or something. It's not smarter than that. And it's following a very narrow set of programming. Whereas you and I are capable of learning all kinds of new skills on the fly and adapting our behavior. Knowledge at Wharton. I understand that because of the artificial general intelligence that Vicarious is developing, you're able to solve some pretty tough programs that narrow AI has not been able to solve. Such as correctly identifying CAPTCHAs, completely automated public Turing tests to tell computers and humans apart. Can you talk about that a little bit more? Phoenix. We published some research in the journal Science this year about how we were able to use our more general vision systems to understand the contents of text-based CAPTCHAs and circumvent them. And so that was one of the research papers that we recently published. And really, what it's all about is not necessarily solving CAPTCHAs. It's about showing that we can build a vision system that has the same kinds of properties that the human neocortex has, and apply that not just to CAPTCHAs, but also to a wide range of different problems, such as recognizing objects in an industrial environment on a robot. Knowledge at Wharton. One of the examples that you like to highlight was that a regular AI could be fooled by such things as making a screen brighter, and suddenly they get confused. Whereas the kind of AI you're developing will actually see through that, and continue working. Phoenix. One of the misconceptions, I think, that I see regularly applied to AIs of today is that when people see a system do something that is intelligent in its behavior, like play Atari or play Go, they assume that it's intelligent in the way a human is intelligent. So, they assume that that system that can play Go can also play checkers, or play chess. And really, in order to go from playing Go to playing chess, it needs to be completely retrained from scratch. The human equivalence is about 3,000 to 5,000 years of continuous, 24/7 playing of chess, in order to learn how to play chess. And after learning how to play chess, it can't play Go anymore. So it's a very, very narrow intelligence. And a common misconception I see is that people will read a story in the news, and they assume that means that the AI is really smart. And it doesn't really mean that. It just means that the AI is able to do a narrow task in a very particular narrow circumstance. Knowledge at Wharton. What are the practical applications of your technology? Phoenix. Right now, in order to get a robot to do something, you have to program it using a series of joint configurations. Basically, tell it to move its arm through a sequence of waypoints. And as you can imagine, that's very error-prone. If I ask you to make a sandwich, but instead of just asking you to make a sandwich using bread and peanut butter and jelly, I told you where to move your arms in 3D space as a list of commands, it probably wouldn't work very well, and it would probably take a long time. And so it's those kinds of problems that you really need a more general AI in order to solve. And that's what we're working on solving at Vicarious. Knowledge at Wharton. What products do you see coming out of your technology? Phoenix. Our first product is an intelligence layer for robots that helps robots to do tasks that currently humans have to do inside of warehouses and factories. So it's things like assembly and packaging that robots for a long time have been physically capable of doing, but they've been too expensive or difficult to program to do. Knowledge at Warden. Are you primarily targeting the enterprise sector, the consumer sector, or both? Phoenix. We're focused entirely on the enterprise sector for now. And I think that's the way a new technology like this needs to be adopted. The nice thing about a factory or a warehouse is that it's very consistent. There are a lot of regularities that we can take advantage of, in terms of the kinds of objects that are being manipulated, and the types of operations that are done to those objects, and how well controlled the environment is. In a person's home or an office or an unconstrained outdoor environment, there's just a lot more variation. And so it's a much tougher task for an AI system to solve. So I think the order will be first solving it for the enterprise, and then eventually solving it for the consumer. This is best for human being. Thanks for watching.